Okay, on to part 2 of the first lesson. So we are on example 5. Benoit and Hannah have left. And I'm trying to finish this up because I need to get out of here when carpool ends, because I'm going to get blocked in and I have to get Christy somewhere by 5 o'clock. So it's really important. So I'm going to leave like right at 4. I don't have much time, but I'm hoping to finish these 2 examples and then maybe get those uploaded when I get home. And then I'll finish the other set, example 7, 8, and 9, maybe tomorrow morning or something. Or tonight if I'm feeling ambitious. Okay, so example 5 says, find the number of terms in these arithmetic sequences. So A is 50, 47, 44, ... There's a bunch of missing numbers, but we don't know how many, and then 14. So in order to find how many terms are in this sequence, we need to find what term number 14 is. Okay, that will tell us how many terms are in the sequence, because if it's the 10th term, then there's 10 terms in the sequence, right? Makes sense to me. So that's what we're going to do, is we're going to find the term number for 14. Well, I always tell my students, start with the formula. So the formula that I gave you in the previous example is the nth term equals the first term plus, and it's n minus 1 times the common difference. So think for a second, what are we trying to find here? What exactly are we trying to find in this formula? We're going to end up with one variable and the rest of the stuff plugged in. So what do you suppose? Just think for a second what we're trying to find. Are we trying to find un? Are we trying to find u1, n, or d? I'll tell you, we're only finding one of those, and all the rest of them, we know them. So think for a second what that is. If you said we're finding n, you would be correct. We are trying to find n. And the difficult part is, a lot of people don't realize that you know what un is. You know un, for an example like this. Un is actually 14th. That's your nth term. That's your last term. That's the term that since we're trying to find the term number for 14, then that is our nth term. So 14 is equal to the first term plus n is what we're trying to find, so we'll just leave it as n, and the common difference is 3. Distribute. Combine like terms, and I'm not going to do too much in my head right now. Combine like terms. Move the 47 over to the left-hand side. Negative 33. I did something wrong. That is not right. Oh, I'm sorry. That's why I messed up. The common difference is negative 3. Duh, it's decreasing. Now I feel like an idiot. So let me go back and fix that. It's negative 3 right there. It's decreasing, so the common difference is negative. Of course. I just told you all that too. So minus and plus. And then minus, and this is three. That's better. So n equals 13. So therefore, therefore 14 is the 13th term. which means there are 13 terms in the sequence. And so that's our answer. There's 13 terms in the sequence. So there you go. Okay, so for B. It's a little bit different. It's A, 3A, 5A. It looks difficult because they have that letter there, but it's really not any difficult than the previous one. So follow the same process as before. 21A is our nth term. Looks like I just ran out of space on this page. Didn't plan that well. 21A is equal to U1 plus n minus 1. Remember, n is what we're trying to find, times the common difference, which is 2A. We're adding 2A each time. So A to 3A is 2A. Not 2, because you can't. A plus 2 is just A plus 2, not 3A. To get from A to 3A, you have to add 2A. And so on and so forth, plus 2A, and so on and so forth. So let's distribute. 21A equals A plus 2AN minus 2A. Let's see, some combining, negative A, I think it's 22A equals 2AN. Divide both sides, we get N is equal to 11. So there are 11 terms in that sequence. There we go. Okay, I made space work. Okay, one more example for this lesson. Example 6. This is on page 11. And the second term, it tells you the second term. So the second term would be U2. And the fifth term, U5, is equal to 21. Find the common difference in the first term. I'm going to teach you something called Logan's method. Logan actually came up with this, and at first I was like, that works. Does it work all the time? He's like, yeah, I'll show you. So he showed me it works all the time. I'm like, okay, yeah, but I don't know if the examiners would like that, because that's not like the way I teach it, you know? So I looked at the mark scheme, and lo and behold, for a problem like this, and by the way, that this is a common exam question on the IB exams, lo and behold, there's like two different ways to do this. You can do it the long, hard way using simultaneous equations, which is how the book did it, or you can use Logan's method, which is a lot shorter and is accepted by the IB. Like, okay, so I'm going to go ahead and show you in this video a Logan's method. If I have time, I don't think I have time, I'll do the solving simultaneously. Basically, you have to come up with two separate simultaneous equations, so they have two simultaneous equations. If you look where it says answer, it says U2 equals U1 plus D equals 15, and U5 equals U1 plus 4D equals 21. Those are your two equations. And then you would solve those two simultaneously. I may tonight or tomorrow morning do a separate video on that, just so you can see, because it is useful to know how to do that, but you're probably going to use Logan's method 9 times out of 10. Anyway, the way Logan's method works is you're going to subtract these two, bigger minus smaller. And I named it after Logan, obviously, because he came up with it. So if y'all see him, you can tell him that it'll forever be his method. So you subtract these two numbers, and that goes on the top of the fraction. And then you subtract these two numbers, and they go at the bottom of the fraction. So it winds up being, 6 over 3, which is 2. And this is going to be, by the way, the common difference. So the common difference is 2. and which is exactly what the book has. So with that said, once you have one of the two formulas, all you have to do is plug that in. The way they came up with the formulas was they said that U5 is 21, so your in U2 is 15. You can use either one. Start with the formula. UN equals U1 plus N minus 1 times D. Well, this is the nth term and this is the nth term. It just depends on which one. You can use both. There's two equations. I'll just use 15. The nth term is 15. U1 we don't know. That's what we're trying to find. In this case, N would be 5 because it's UN. So N would be 5. I'm sorry, not 5. We're using 15, so it's 2. So this is 2 minus 1. And we already know the common difference using Logan's method. And again, I'll do a separate video a little bit slower on how to come up with your two equations. I'm just coming up with one equation because we only need one. But if you were not using Logan's method, you would need both equations. So being 2. So U1, the first term, equals 13. So there's your two answers. It just asks for the common difference in the first term. So, and there you go. And that's a very common exam question. It's not difficult at all. It's one of the easier ones. You would actually probably hope they put that on your exam. I know it may seem hard now, but it's one of the easier ones. So anyway, once you get used to it. So anyway, you can start working on exercise 1B, and I will at some point be sending y'all an email telling you that I've uploaded videos for the next set. And I told Hannah and Benoit that they're welcome to work on this over the weekend if they don't want to have extra homework next week. I'm planning on starting with the next lesson on Monday. I'm going to kind of talk to y'all about it, see, because if you haven't done any of this over the weekend, then you may be really confused. Well, no, you wouldn't be, because Monday we're going to start with geometric sequences series, which is very different than arithmetic. So you wouldn't have had to do the arithmetic in order to do the geometric. So you could then, spend your time catching up on the arithmetic if you wanted to. Although it would be preferable if you have time to do it over the weekend, obviously, that would be nice. But I know y'all may have plans and whatnot. So we'll talk about it on Monday and try to figure out a plan and all this stuff. But I will be uploading the videos just on the off chance that you may have time and you would like to work on it. So anyway, all right. Well, y'all email me if you have any questions or concerns or anything. I don't want to stress y'all out or overwhelm you too much. But anyway, I know I'm spending my weekend doing work. I have tons of planning still to do. So I still have 3 more pacing calendars, and then I still have to make the schemes of work for those. So I have a lot of work to do. So I will be doing work this weekend, but I don't know about y'all. Anyway, so there we go. I'll see y'all on Monday. Have a great weekend.